Salam, peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Part 33. When the language becomes a world, a bridge to physics. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We now continue our profound journey through Episode 8, the pure abstract language of the Holophase audio series, moving to Part 33, When the Language Becomes a World. Book 8.9, The Bridge to Physics. For 32 parts, we have been pure architects. We have lived in a realm of pure possibility. We started with the solitary letter phi, learned to form words from its derivatives, discovered grammar in the way those derivatives are related, explored meaning in patterns, understood information as constraint, and watched time, space, and motion emerge as three inseparable echoes of every change. We proved that this language cannot contradict itself, that it can describe any coherent pattern within its domain, and that it still carries a humble limit when it tries to speak about itself. We have been standing inside a perfect, silent library of all conceivable stories. Now, we stand at a threshold. The abstract cathedral is complete. Its arches are flawless. Its symmetry is perfect. Its equations are beautifully balanced. But it is still empty. It has perfect acoustics, but no sound. It has beautiful arches, but no stone. It is a language with perfect grammar, but no speaker, no listener, and no book actually printed and read. If we stopped here, Holophase would remain a beautiful philosophy of pure structure. It would be like discovering the rules of music and then never hearing a single note. Some people enjoy playing only with abstract patterns, and there is great value in that. But the promise of this program has always been bigger. We are not only building a language, we are claiming that this language is the one the universe itself uses. That claim must touch measurement, experiment, and the rough edges of reality. Today, we take our first step out of this silent library and into the noisy, messy, magnificent world. Today, we begin Book 8.9, The Bridge to Physics. We are not yet doing detailed physics. Instead, we are preparing the doorway. We are asking a simple but profound question. What happens when our perfect, abstract language meets the imperfect, tangible world? What changes when phi stops being only a pure idea and becomes something that can be measured, something that can be wrong, something that can break? This is the story of the moment when the language becomes a world. 1. The story core. When phi meets measurement. Imagine you are a composer. You have spent years in silence learning music theory. You understand scales, chords, harmony, counterpoint. On paper, you can write a flawless symphony. Every note is perfectly chosen. Every rhythm is mathematically precise. This silent score is like the pure phi language, a complete, exact, noiseless description. Now you gather an orchestra. The musicians sit down. They lift their instruments. They breathe in. They begin to play. Suddenly, the perfect abstraction becomes a physical performance. One violin is slightly out of tune. A cellist bow scratches for a moment. The trumpeter breathes a little too early. The concert hall adds echoes. Someone coughs. The recording microphone has a faint hiss. The air itself absorbs some frequencies and amplifies others. It is still your symphony. The core structure remains, but it is now clothed in wood, brass, breath, air, and human limitation. The perfect score has met the real world. This moment is exactly the kind of moment we are interested in now. The pure phi language is the silent score. Physics is the living orchestra. Implementation is the act of turning abstract sentences in phi into concrete patterns in some physical medium. Measurement is what happens when another part of the world, or an observer, tries to listen to that performance and read it back. You can feel the same difference in many everyday situations. A recipe in a cookbook is like an abstract phi pattern. Cooking the meal in your own kitchen with your imperfect oven and your tired hands and the exact vegetables you found in the shop is the implementation. Serving and tasting the food is measurement. Sometimes it works beautifully. Sometimes it burns. The bridge between the ideal and the real is always a place of surprise. So the first key idea of this bridge is very simple. Our pure language is not enough. To meet reality, it must be implemented and it must be measured. 2. Linguistic role, from alphabet to printed book. In our grand language metaphor, everything so far in Episode 8 has been about inventing the most powerful alphabet and grammar possible. Phi and its derivatives are our letters. Their relations are our grammar. We can, in principle, write any coherent story in this language. But a story that exists only in the mind of the author is not yet a book. A book has to be printed. It must exist in a medium, ink on paper, pixels on a screen, vibrations in a voice. Once we print it, we discover new constraints. Ink can smudge, paper can tear, screens can flicker, voices can crack. Printing a book also forces choices. Which font do we use? Which size? Which layout? How wide are the margins? In the same way, implementing phi in a particular physical medium forces concrete decisions. Which degrees of freedom of the medium carry which parts of the phi pattern? Which aspects are ignored, approximated, or compressed? The bridge to physics is the move from I can write any story to I can print and read this story in a real medium with real limits. Physics is not a different language from phi. Physics is phi written into a particular substrate, the actual universe, and then read back by that same universe using physical instruments. So the linguistic role of this bridge is to explain how we translate between the ideal sentences of the phi language and the actual, limited, noisy sentences we see as physical phenomena. It is the study of translation rules, distortions, and invariants, what the printing process changes and what it must never change if the story is to remain the same. 3. Scientific essence, the question of faithfulness. The crucial scientific question at this bridge is, how faithful can a physical implementation be to the abstract phi pattern it is supposed to represent? In pure abstraction, if we say the third derivative of phi has exactly this curvature at this point, then that statement is exact. There is no error. There is no uncertainty. It is simply true or false. In the physical world, any attempt to realize that pattern passes through a medium. Maybe the relevant medium is the electromagnetic field, or a crystal lattice, or a fluid, or the state of a quantum field. That medium has its own properties: friction, thermal noise, quantum fluctuations, imperfections, boundaries, delays. It can also have constraints like conservation of energy, speed limits, and stability requirements that do not appear in the pure mathematics. So we ask, if the abstract phi pattern demands a very delicate structure, can any physical medium actually realize it? Can it hold that pattern long enough to matter? Can we measure it without destroying it? Can multiple copies be made so that different observers can agree that they have seen the same thing? This is not a side issue. It sits at the core of what physics is. If the Holophase view is right, then physical law is the description of which phi patterns are robustly implementable in our universe. The pure language tells us what is logically possible. Physics tells us which of those logical possibilities are practically stable and observable given the particular hardware of our cosmos. Another way to say this is, the abstract phi language tells us which stories are grammatically possible. Physics tells us which of those stories can be staged as real plays on the cosmic theater. Some scripts are too fragile, or require props that do not exist, or need a stage that our universe simply does not provide. This is why the bridge is also a test. If we can identify a pattern that is clearly needed to describe some physical phenomenon, but which cannot be implemented as a phi pattern without wrecking the grammar, then our framework has a problem. Our map would have torn at exactly the place it needed to fit. 4. Falsifiability, when abstract patterns refuse to appear. To make this more concrete, imagine an abstract knot in the phi language. Topologically, it is a precise entanglement of loops. It has clear invariants like a linking number. The language says, this knot is a stable pattern. Now try to implement this knot in different media. Tie it in a shoelace. Shape it using vortices in a fluid. Encode it in the phase of a light beam. In each case, you are trying to embody the same abstract phi knot in a different physical substance. If the holophase picture is right, at least one physical medium should be able to hold this pattern in a stable way, because the stability comes from the topology of the pattern, not from the details of the medium. Topological patterns are supposed to be robust under smooth deformations. But suppose we discover a pattern that the abstract language insists should be stable, yet every attempt to build it in nature fails in a fundamental way. Not just because we are clumsy, but because deeper physical principles prevent it. The knot always unravels. The linking number cannot be maintained. No physical field can actually realize that configuration while respecting other well-tested laws. Then we must face a hard question. Either our mapping from the abstract phi pattern to the physical implementation is wrong, or the abstract language is missing some deeper grammatical rule that forbids this pattern even before we go to physics. In other words, either we made a mistake in translation, or our dictionary itself is incomplete. In either case, the bridge gives us a concrete falsifiability lever. The abstract library is not allowed to drift freely above reality. It must be anchored by what the world can and cannot do. The moment we find a truly coherent pattern that reality refuses to host, we have learned something fundamental about the limits of our language, or about the nature of our universe, or both. Fifth, dimensional expression, how imperfections echo. Even when an abstract pattern can be implemented, the three echoes of time, space, and motion now carry the signature of the medium. In pure abstraction, time is a perfectly sharp ordering. One moment follows another. Periods and frequencies can be defined with infinite precision. In physics, we measure time using clocks. A clock is itself a phi pattern implemented in matter. A swinging pendulum, a vibrating crystal, an atomic transition. No clock is perfect. It jitters. It drifts. At the quantum level, there is fundamental uncertainty. The time echo becomes smeared. We can talk about now, but only within a small window of uncertainty. Similarly, in pure abstraction, space is a perfectly smooth backdrop. Distances and shapes can be defined exactly. In physics, we measure space with rulers, interferometers, and detectors, all built from atoms and fields. They expand and contract with temperature. They have finite resolution. At small scales, quantum effects disturb positions. The space echo becomes grainy and fuzzy. For motion, the same happens. In pure abstraction, motion is a perfect mapping of positions through time. In physics, motion is always motion through a medium that resists, absorbs, and radiates. Waves in water lose energy. Particles radiate when they accelerate. Even light is affected by the geometry of space-time. The motion echo is mixed with friction, drag, and dissipation. These imperfections are not merely annoyances, they shape which patterns survive. A wave that theoretically could last forever in the pure language will always decay in a real medium. A crystal pattern that is mathematically possible might never form because the cooling process introduces defects. A perfectly symmetric configuration in phi might be broken by a tiny fluctuation that gets amplified as the system evolves. So the bridge to physics changes our three dimensions from perfect, sharp X's into measured, imperfect, noisy echoes. Time, space, and motion remain the three shadows of change. But now, those shadows fall on a rough surface that adds its own texture. 6. Position in the master tree. Roots touching soil. Inside the master tree of the Holophase language, everything so far was like growing a perfect tree in the air. We described roots, trunk, branches, leaves, and fruit, but we did so in a weightless, frictionless space of pure logic. The bridge to physics is the moment when the roots actually touch soil. The soil here is the physical universe, the actual way phi behaves when it is not just considered as a concept, but as the real underlying field of existence. This soil has its own chemistry. It allows some patterns to grow easily. It suppresses others. It may make some abstract possibilities incredibly rare or effectively unreachable. From this point on, the question is no longer what can the language express, but which expressions does the world prefer? Which ones are stable, abundant, and observable? The laws of physics, in this view, are not arbitrary external rules. They are the stable, self-consistent, self-reinforcing phi patterns that our cosmic soil naturally supports. Symmetries that are easy for this soil to sustain become conservation laws. Instabilities that are hard to avoid become arrows of time. Certain combinations of derivatives become the native phrases of our universe, repeated again and again in different contexts. You can even think of different physical regimes, like the early universe, the interior of stars, or the conditions inside a living cell, as different types of soil with different nutrient mixes. The same abstract tree of phi can grow very different shapes depending on where its roots are planted. 7. Relations to neighbors, bringing the whole language along. This bridge does not throw away anything we have built. It brings it all along and asks how each piece behaves under implementation. Topology asks, which knots, braids, and defects can real fields actually support? We see answers in superconductors, superfluids, liquid crystals, and even in cosmic strings. Each successful realization strengthens the bridge between abstract topological language and physical reality. Holonomy asks, can real systems remember the history of how they were moved and still show that as a measurable phase or twist? The Aronoff-Bohm effect shows that they can. A loop taken around the region with magnetic flux leaves a measurable memory in the phase of a quantum wave. This is the abstract idea of path-dependent phase made concrete in an experiment. Information and complexity ask, how much structure can be stored, transmitted, and transformed by a physical phi pattern before noise and dissipation erase it? Thermodynamics and information theory answer with concepts like entropy, capacity, and error-correcting codes. The abstract idea of constraint meets the physical idea of energy cost. The action principle asks, do real systems behave as if they are following a rule of optimality? In classical and quantum physics, they often do. Real trajectories, waves, and fields can often be recovered from a simple abstract least action story, even though the actual physical processes are full of local interactions and exchanges. The principle of stationary action becomes a compressed description of a vast number of microscopic interactions. The bridge sets the stage for all of these abstract ideas to show their faces in the laboratory. It also reminds us that every time an experiment confirms an abstract principle, what is really being confirmed is the ability of phi patterns in this particular universe to faithfully implement a certain piece of grammar from the Holophase language. 8. Semantic meaning, the work of embodiment. What is the deeper meaning of this bridge? At the most basic level, it says that meaning is not complete until it is embodied. A sentence, no matter how perfect, is not a lived reality until it is spoken, heard, and allowed to change something. A law written on paper does not shape society until it is enforced, challenged, and woven into daily life. In the same way, phi patterns are not yet worlds until they are implemented in the actual field that is our universe. Implementation is how the language becomes a world. Measurement is how the world reads itself. Interaction is how different sentences in phi influence each other, collide, merge, and give rise to new stories. This means that physics is not less real than abstract mathematics. It is the arena in which the living field of phi shows us which parts of its abstract library it chooses to enact. Theorems become experiments. Possibilities become histories. It also suggests a new way to think about beauty in physics. A beautiful theory is not only elegant in abstraction, it is also one whose patterns can be implemented in many different physical contexts with surprising robustness. Beauty is the harmony between abstract grammar and physical soil. 9. Recognition skill, seeing ideals and realizations. How can you begin to feel this bridge in your own experience? Look for any situation where there is a clear ideal pattern and a messy real version. Think of handwriting. The letter A has a perfect printed form, but every person's handwritten A is a little different. The ideal A is like the abstract phi pattern. The handwritten A on paper is like a physical implementation. You can recognize the letter even when the implementation is sloppy. Your brain is constantly bridging between abstract forms and physical examples. When a child learns to write, they are literally learning how to implement the abstract alphabet in the physical medium of paper, pencil, and muscle control. Think of a map in a city. The map is a simplified ideal representation. The city is noisy and complex. Streets are under construction, new buildings appear, old ones decay. Yet, the map helps you navigate, and the city gives the map its meaning. Neither is complete alone. The map without the city is empty. The city without the map is harder to understand. Together, they form a dialogue between ideal and real. Think of your own intentions and actions. Inside your mind, you can form a clear plan. Tomorrow, I will wake early, exercise, work deeply, and speak kindly to everyone. That plan is like an abstract pattern. The next day, reality intervenes. Your alarm fails, you feel tired. A difficult conversation triggers anger. The plan meets the world. Some parts survive, some parts fail. By the evening, you have a new understanding of both your ideal and your limits. This is exactly the relationship between the pure phi language and the world. The language gives us maps. The world gives us the city. The bridge is where we check, over and over, how well they match, and where both map and city are refined by that comparison. X. Return to phi. One substance, two ways of seeing. We end this part, as always, by returning to the core simplicity. We are not introducing a second fundamental thing besides phi. We are not saying, here is abstract phi, and here is some other physical substance. We are saying, there is only phi. The difference between language and world is a difference in how we look at phi. When we look at phi as pure possibility, stripped of noise, friction, and limitation, we see the abstract language. When we look at phi as it actually behaves, interacting with itself, producing clocks, rulers, detectors, stars, cells, and brains, we see physics. The bridge to physics is simply the disciplined way of moving between these two views, making sure that our abstract stories are always answerable to what the universe actually does. It is a commitment to let reality speak back to our theory, and to let our theory refine how we listen to reality. If you wish to explore the full mathematical details of this bridge, how the same phi equations can be written as physical field theories, and how measurement and noise are treated, you can search for Holophase on Zenodo, where the formal papers live. Zooming out, remember, everything we have discussed is still just one field, phi, and its derivatives, the single language the universe uses to write every story. In episode 8, we build that language in its purest form. With this part, we have walked to the edge of abstraction and looked out over the landscape of physics. From here, the journey turns. In the coming episodes, we will cross this bridge step by step. We will watch phi wear the costumes of mass, charge, force, light, and matter. We will see how familiar physical laws appear as specific, stable sentences in the Holophase language. We will trace how the three echoes of time, space, and motion organize themselves into the concrete things we see and touch. For now, stand at this threshold. Behind you is the silent cathedral of pure ideas. Ahead of you is the bright, noisy theater of the physical universe. Know that, in this vision, both are expressions of the same eternal field. You are not just learning about phi. You yourself are one of its patterns, listening to its story about itself and choosing how to continue that story in your own life. 11. Looking ahead, from bridge to journey. Before we close this part, let us look at what this bridge will change in our journey. Up to now, whenever we said phi does this or a derivative behaves like that, we were speaking in a weightless way. We describe structures that could exist, relations that are logically allowed, patterns that fit together without contradiction. In the next episodes, when we say phi does this, we will mean something stronger. We will mean phi, as the real field of our universe, behaves in this way. And if it does not, our theory is wrong. At the level of time, space, and motion, we will no longer be content to say these three dimensions co-emerge from derivatives. We will ask, what are the actual units, scales, and symmetries of these dimensions? Why is there a finite speed of light? Why does time seem to have a direction? At the level of fields and particles, we will move from the statement, localized excitations of phi can behave like particles, to concrete proposals. We will ask which combinations of phi derivatives correspond to known particles, such as electrons, photons, and quarks. We will explore how familiar forces, electromagnetic, weak, strong, gravitational, appear as particular coupling patterns in the holophase language. At the level of information and complexity, we will stop speaking only about constraints in principle and begin to talk about communication channels, energy costs, and limits of computation inside a finite universe. We will connect the field that carries light across space with the field that carries signals in your nervous system and bits in optical fibers. Most importantly, at the human scale, we will connect the abstract picture you have learned with the everyday world you live in. We will show how the cup of tea in your hand, the warmth of the sun on your face, the flow of traffic in your city, and the thoughts in your mind can all be read as different dialects of the same underlying phi story. Remember the overall picture. There is one field, phi, and its infinite hierarchy of derivatives. From its first differentiation, time, space, and motion appear together. From their ongoing echoes, all patterns arise. In episode 7, we climbed the master tree of this language. In episode 8, we explored its abstract architecture, its consistency, its universality, and its limits. Here in part 33, we have reached the point where that tree bends down and its roots touch the soil of physics. From now on, every new concept we introduce will live double lives. One in the clean world of phi equations, and one in the messy world of experiments and experience. The art of holophase is learning to see both at once, and to remember that there are two views of one reality. Salam, and peace be upon you.